In a given arc welding operation, the power source is at 20 volts and current at 300 amperes. If the electrode travel speed is 6 mm per second, calculate the cross-sectional area of the joint. So cross-sectional area of the joint means A, capital A. We have to find capital A. The heat transfer efficiency is taken as 0.80 and melting efficiency as 0.30. Heat required to melt the steel is 10 joules per mm cube. So here operation is arc welding operation. Here operation is arc welding operation. Arc welding operation. Okay. This is arc welding problem. Let's solve this problem. So first of all, here given power source is at 20 volts. Voltage is given. So power source voltage V is equal to 20 volts. Next, given current. Current denoted by capital I is equal to 300 amperes. Capital A means unit of current, amperes, capital A. Okay na? So voltage ichchodu, next power ichchodu, I mean current ichchodu. Next, if the electrode travel speed is electrode, we use electrode in arc welding process, so electrode travel speed. So electrode travel speed is 6 mm per second. So electrode travels denoted by small v. V is equal to 6 mm per second. Small v is equal to 6 mm per second. Next, calculate the cross-sectional area of the joint. The heat transfer efficiency is taken at 0.80. Heat transfer efficiency. So heat transfer efficiency given eta H. Heat transfer efficiency as 0.80 and also given melting efficiency. Given melting efficiency eta m is equal to 0.30. Also given heat required to melt steel is how much given? Heat required to melt the steel, let us say capital H is equal to given 10 joules per mm cube. 10 joules per mm cube. Heat required to melt the steel, H is equals to 10 joules per mm cube. This is given data. So at last we have to find cross-sectional area of the joint. Cross-sectional area of the joint. So cross-sectional area of the joint denoted by capital A is equal to what? So this is question. Cross-sectional area of the joint is what? So first of all, here given power source voltage and current. Now let us find first step 1. Let us find heat input by the power source. Heat input by the power source HI denoted by HI. So HI is equal to what? HI is equal to voltage into current. Okay. Heat input by the power source HI is equal to voltage into current. Heat input is equal to voltage, how much? 20 volts into power 300 amperes. So voltage ampere means watts. So power unit watts. So 20 into 300, 6000 volt ampere means power unit watts. 1 volt ampere means watt. So 6000 watts. So the power input or heat input by the power source is 6000 watts. This much power supplied by the power source. Next we have to calculate heat input into the workpiece. Okay, anyhow, okay, we supplied some power. How much heat taken by the workpiece? So next we have to find heat input into the workpiece. So heat input into the workpiece. So denoted by HW. Okay, now we have to find HW. Input into the workpiece, HW. So heat input into the workpiece, HW is equal to heat transfer efficiency, HTE, heat transfer efficiency into heat input by the power source, HM. Heat input by the power source. So HW is equal, here HW means heat input into the workpiece. ఎంత హీట్ వర్క్ పీస్ లోపలికి వెళ్ళింది తీసుకుంది. సో HW is equal to heat transfer efficiency into heat input by the power source. Now HW is equal to, so heat transfer efficiency how much given? 0.80 into heat input by the power source or power supplied by the power source. How much? 6000 watts. 6000. HW is equal to, if you calculate, you will get 0.80 into 6000. You will get 4800 watts. 4800 watts. This is HW. Okay, this much heat taken by the workpiece. So next we have one more formula, melting efficiency, ETIM. So melting efficiency is equal to HM by HW. So melting efficiency is equal to HM by HW. What is HM? Here HM is equal to amount of heat required, for melting, workpiece. So amount of heat required for melting workpiece. So what is HW? Here HW means heat input into the workpiece. So here we have ETIM and HW. We can find HM. Now HM is equal to what? So amount of heat required for melting workpiece is ETIM into HW. Okay, now transpose HW. So ETIM already given, melting efficiency 0.3 into HW how much? 4800. Okay, now multiply these two. 0.3 into 4800, HM is equals to 0.3 into 348 is 144. You will get 1440 watts. 1440 watts. So therefore amount of heat required for melting workpiece is 1440 watts. So we have one more formula for HM. HM is equals to volume of, HM is equal to volume of workpiece melted per unit time, volume of workpiece melted per unit time into amount of heat required to melt, amount of heat required to melt unit volume of workpiece, So HM is equal to, little bit lengthy, formula is little bit lengthy but very easy. HM is equal to volume of workpiece melted per unit time, into amount of heat required to melt unit volume of workpiece. So simply we can write it as, So volume of workpiece melted per unit time is equal to cross-sectional area of the joint. So we need this value, cross-sectional area of the joint into travel speed So volume of workpiece melted per unit time is equal to cross-sectional area of work joint into travel speed. So in place of this we can write this. So cross-sectional area of the joint into travel speed into the amount of heat required to melt a unit volume of workpiece is capital H. So capital H already given in the question. So amount of heat required to melt the material is given 10 joules per mm cube. So that is H. And what about HM is equal to, here cross-sectional area of the joint means A into, so travel speed small v into H. So this is the formula for HM. HM is equals to A into V into H. A for cross-sectional area of the joint. Here V for travel speed. H means amount of heat required to melt unit volume of material. Okay, now workpiece. So first of all, HM is equal to volume of workpiece melted per unit time. So volume of workpiece melted per unit time again is equal to cross-sectional area of the joint into travel speed. The amount of heat required to melt a unit volume is capital H. So this is capital A and this is small v. So AVH. Now HM value how much? We already have HM 1440. Cross-section area we don't know. And travel speed. How much travel speed is given? So I think we given 6 mm per second. 6 into H. Okay, no, into H. H is 10 joules per mm. So 6 tens are 60. Now 1440 is equal to A into 6 and 10 are 60. Transpose 60. Now A is equal to 1440 by 60. 0 get cancelled. A is equal to 6 ones are 6 24s are. So therefore A is equal to 24 mm square. Therefore cross-sectional area of the joint is 24 mm square. We got the right answer, 24 mm square.